Everyone, so let's take a look at that first question. So for Poisson process, the definition goes like this, which is we are very familiar with, and the other part of the definition is that if the time interval t1, t2, and t3, t4 are not overlapping, then the random variable n t1 t2, the number of points coming in the interval t1 t2 and n t3 t4 are independent, which means that the Poisson process is independent increment process. Okay, and the mean of this process is lambda t, which makes sense because as t grow up, then the number of point is more like to become larger and larger. Yeah. The correlation of a Poisson process is lambda squared t1 t2 plus the minimum of lambda t1 and lambda t2. And the property of Poisson process is that if two Poisson process t1 t2 are independent, then the sum of these two processes is also a Poisson process, and the parameter of this process is t1 plus t2 times t. It is also very intuitive because since these two Poisson processes are independent, then we can imagine that then the point coming rate is more like to be the sum of these two processes. And the difference of two independent processes is not a Poisson process. And the other property of Poisson is if we randomly select the coming points and group them into another process, then they will become another Poisson process. Meaning, if we check the occurrence of xt and with probability t, then the number of checked points in time interval 0 to t is going to obey the Poisson process, which has the parameter of t of lambda pt. And the conditional distribution of Poisson is obey the binomial distribution. And with the parameter of n and t1 over t2, this is which means that given xt2 is going to be n, the probability of xt1 is going to be k is obey the binomial distribution, which is easy to understand because it's like in the total time interval between 0 to t2, they're going to be in totally n numbers, and we want k of them is occurred in the time interval between 0 and t1, and since this Poisson incoming points is independent and kind of like uniform distribution between t0 to t2, then the probability that this point coming occur between time interval 0 to t1 is t1 over t2, right? So, which is pretty obvious to understand. And if we make tn is equal to k and equal to 1, then we can easily find out that the Poisson arrival time obeys uniform distribution. And the next is Poisson increment process. If we want to figure out this process, which is the coming rate between t and t plus 3c over c, which means that we want to normalize the time interval of t to t1 t plus c, and it's more like a coming rate of Poisson process, and we know that t is and the probability function, mass function, is going to be like this, and the mean of this process is lambda, and we can find out that this process is WSS process. Next is normal process. The definition of normal process is that the xt1 blah 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 xt to xtn is jointly normal, a jointly normal distribution for all n, and the characteristic this process is determined by the mean of xt and the correlation between xt1 and xt2 for all t1 t2. So that's it. That's the first problem.